Welcome back to another explainer. If you're the kind of person who just has to know what's going on under the hood, you are absolutely in the right place. Today, we're dissecting a fascinating electronic map, the Heavy Bass Amplifier Circuit. It's a design credited to Takno Mastr, and we're going to demystify the whole thing. We're breaking down those complex pathways of electricity and sound so you can see exactly how absolute silence gets transformed into heavy, thumping bass.
All right, let's just jump right in. What you're looking at here is the complete wiring diagram for this amp. Now, at first glance, it kind of just looks like a chaotic web of colorful lines and technical components. But we're going to turn this static image into a dynamic, step-by-step journey. We'll track the actual physical path of an audio signal. And by the end of this explainer, I promise you, every single wire on this board is going to make perfect sense.
So here's our game plan for today. First, we'll meet the TDA7388 amplifier itself. Second, powering up with 12-volt DC. Third, filtering the audio inputs. Fourth, the peripheral support components. And finally, driving those speaker outputs.
Part 1. Meet the TDA7388 amplifier. To really grasp how the signal flows here, we've got to look straight at the brain, or honestly, the beating heart of the whole operation. Just look at the sheer size of this thing right at the top center. This is the TDA7388 integrated circuit, or IC. Literally everything in this diagram, all the power, all the audio, routes directly into and out of this one massive piece of hardware.
Let's check out the specific identifiers stamped right on the chip, just to really anchor our main character before we set it in motion. Right at the top center, you've got that distinct ST logo, which stands for ST Microelectronics. Right below that is the main ID, TDA7388. It's also got a few manufacturing codes, 124DMA-TKX, MLT-BB125, and the number 25 kind of off to the right. Plus, you'll see soldering tech printed near the bottom pins, and hovering just above the whole chip, the entire schematic is credited to by Takno Mastr.
Moving on to part 2, powering up with 12-volt DC.
Now, an amp doesn't just magically pull louder sound out of thin air, right? It needs some serious electrical energy to physically drive that amplification. Let's see where this circuit gets its food. Check out the very top edge. See that thick red wire and the black wire coming in? That is our 12-volt DC line dumping raw power straight into the circuit. The black wire snakes down to the right side of the chip's pins, while that bright red wire feeds down along the left side.
And you know, this perfectly illustrates a really cool fundamental concept in audio electronics. Think about the contrast happening on this board. Up top, you've got this raw, high-power 12-volt DC input, which is literally the brute muscle. And we're going to contrast that brute muscle with the incredibly delicate, low-voltage audio data that's about to enter from the bottom.
Which brings us to part 3, filtering the audio inputs.
All right, so we've got the muscle. Now let's talk about the senses, where the actual audio dialogue starts its journey. Down at the bottom center, you'll spot a set of purple wires clearly labeled L, GND for ground, and R input. If you trace those purple lines flowing upward, you'll see that before the left and right audio channels can even reach the main amp chip, they have to pass through some specific gateways. They flow right through pairs of green capacitors. Specifically, the signal pushes through a 100 NF capacitor and then a 10 NF capacitor on both the left and right sides.
So let's break this down into 4 exact steps to see how it builds a complete logical pathway. Step 1. The raw audio signal enters via those L and R inputs at the bottom. Step 2. That signal gets filtered through the 100 NF and 10 NF green capacitors, which essentially prep and clean up the audio. Step 3. The big TDA7388 IC receives that clean signal, takes that 12-volt muscle from the top, and massively amplifies it. And finally, Step 4. That newly amplified heavy bass signal exits the chip, headed straight for the speakers.
Part 4. The peripheral support components.
Now, the TDA7388 chip is obviously the star of the show, but it definitely can't do this alone. It needs a supporting cast flanking it to keep everything running safely. Before we trace their wiring, let's just quickly catalog what we've got. On the left side, there's an R10K resistor next to a black diode, and over on the right side, we've got a green 470 nanofarad capacitor and an R100K resistor.
Zooming in on that left side, look closely at how the R10K resistor and the black diode are physically wired in. They're interacting directly with that red power trace dropping down from the 12-volt DC input. Essentially, they act as guardians on the power line, managing the voltage and making sure current is flowing exactly where it should. Panning over to the right side of the main chip, we see that green 470 nanofarad capacitor and the R1000K resistor connected in a circuit along the edge of the TDA7388 pins. The main takeaway here is that these flankers on the left and right, they aren't just spare parts. They're absolutely crucial for stabilizing the chip's internal operations and handling the electrical load when that heavy bass really kicks in.
So, we've built up the entire system, but it begs the question. After sucking up that 12-volt power, taking in the audio inputs, and filtering through all those vital support components, where on earth does this massive, heavy bass signal actually end up?
Section 5. Driving the speaker outputs.
Here is where we finally reveal the voice of our circuit. This is the final destination, where all those electrical signals literally get pushed into the air as sound. Notice the 4 speaker cones, arranged symmetrically on the left and right. See those thick red, green, and black wires exiting the bottom array of pins on the IC chip? The amp is taking all that processed energy, splitting it up, and sending it rushing down those wires straight into the voice coils of these 4 speakers.
Now, I do want to point out a pretty fascinating quirk written right onto the schematic. If you look at the text beneath the speakers, the creator, takno mastr, labeled the top left, bottom left, and top right speakers all as output left 1. Only the bottom right speaker gets the output R1 label. It's a super specific design choice, making 3 out of the 4 outputs technically designated to the left channel path.
Stepping back for a second, let's look again at that overarching title printed in bold red at the top, Heavy Bass Amplifier Circuit. It really ties this whole thing together, doesn't it? You can clearly see how the 12-volt muscle, the carefully filtered inputs, that robust TDA7388 IC, and those 4 speakers all work together in perfect harmony. It's just a beautifully structured ecosystem designed from the ground up for one single purpose, to hit you with heavy bass.
Well, we've successfully navigated the map. And now that you've traced the complex audio flow of a TDA7388 amplifier all the way from the raw power down to the physical speakers, I want you to just look around you for a second. Think about it. What invisible electrical pathways are carrying signals inside the devices sitting right next to you? The headphones on your desk, your TV, your car stereo, they all rely on the exact same kind of precise, structured logic we explored today. Keep wondering how things work, keep that curiosity sharp, and I'll see you in the next explainer.